Good morning everybody. I am Dr. Hari, Associate Professor, Department of Physics, National College. I am here to demonstrate how to execute, how to type and how to compile an assembly language program using 8085 architecture. It is a microprocessor kit, and first of all we want to know what do you mean by a microprocessor. A microprocessor is nothing but a CPU, central processing unit of a microcomputer. So, we are going to now first type the program by using the kit, and this is the microprocessor kit of 8085 architecture, and the 7-segment display will be here. It consists of 6 segments or 6 digits. The first 4 digits will indicate the memory address that we are going to store our program, and the last 2 digits is the area where we are going to load our program, and we are going to give the input, and finally we are going to check the output. In the starting process of this microprocessor kit, we have to use certain operations so that the program will be executed without any troubleshooting. Here is an option called reset. So, to start the program, we can switch on the kit. It will display 85, mu 85, which indicates that this microprocessor kit works under the architecture of 8085. So, for starting the program, we have to give reset, substitute, and then we have to start the memory address typing. The memory address for this microprocessor kit can be from 4000 to 8500. It depends upon the user where the program has to be executed, in which address it has to be loaded, and in which address it has to be compiled. So, by pressing reset, substitute, and then by using the option next in this kit, then we have to start typing the program, and we have to go on continuously typing the program until the program halts. The final operational code for this is 76. 76 indicates the stop or termination of the program. This is the first part where we can type the program without any disturbance. The second part is that we have to feed the input, for which we have to obtain the output. For going for input, we have to give reset, substitute, and input address. The input address entirely depends upon the user where they want to load the value. If there are more than one inputs, by using the option next, we can able to type 1 or 2 or n number of inputs as required by the program. And after typing the inputs, we have to compile the program, and for compiling the program we have to go for reset, go, and the starting address of the program, and there is an option called execute. By pressing the execute button, the microprocessor kit may able to give 2 types of result. One of the result is said to be E. E indicates that there is no error and the program was completely executed. Sometimes there may be a typographical error or any systematic error, so that the E will not be executed. This is the second part of the program. And the final part is that we have to check the output. For checking the output, we have to go for reset, substitute the output address where we are supposed to load the output, and finally by pressing the button next, we will be able to getting the output. For demonstrating this concept, I am going to choose a very simple program, that is we are going to add 2 8-bit numbers by using 8085 architecture, and by adding the 2 8-bit numbers we are going to store the result, so that the result is also said to be only an 8-bit, which indicates that there is no carry in this output. And for this we have already have a typed format of program. In the program, it contains memory address. Memory address is the area where we have supposed to load the program, and there will be another option called opcode, or it means that operational code, which is to be executed for this assembly language concept, and then it will be having mnemonics. Mnemonics is used only for the user to understand, and finally the comments, which explains the step by step execution of the program. In the second tabular column, it contains input address, two inputs and below the input there will be an address, memory address, and then the next column is also an input, and finally an output where the output is to be loaded. Now I am going to type this program in this microprocessor kit. I have completed typing the microprocessor kit. The last digit indicates here is 76. 76 indicates the stop or halt of the program. Now this is the first process. I completely typed the program, and the next process is that I am going to give the input. For giving the input, I have to give reset sub and then the memory address 4151. The memory address has to be decided only by the user. So I am going to simply give two numbers. One is 05 and the next number is 05. So we are going to add 5 plus 5. The output is said to be capital A because the data will be in hexadecimal digits. So for compiling the program, I am going to give reset go starting address and then execute. This shows that this is the capital E symbol, which shows that there is no error in the program. So the third step is that we are going to check the result or check the output. For that we are going to give reset sub 4153 where we are going to store the result. The result indicates 0A, which shows that we are added two numbers 5 plus 5 plus 5 is 10. In hexadecimal it will be indicated as 0A. This is a normal or simple program in such a way that we are supposed to demonstrate the purpose of handling this microprocessor kit without any trouble. Thank you.